Hello. In this video we're going to take a look at how to use loops in Python. Loops are a very important feature of any programming language. They're a powerful tool that allow you to instruct the computer to execute code many times without having to explicitly write code for every iteration yourself. Loops are pervasive in all types of programs ranging from scientific and mathematical data analysis to loading profile data on your favorite social media app. So let's get started in learning how to use loops in Python. As a mental model, I find it best to think of two categories of loops. So the first one we're going to talk about is called a Sentinel controlled loop, spelled like this, Sentinel controlled loops. These are loops that continue to execute until some condition is met. So, and perhaps you don't know the condition beforehand. So, for instance, a common situation where these pop up is user interface applications where somebody's going to continue using your program until they decide to stop. So let's look at kind of a toy example of one of these. I'm going to go ahead and prompt the user for a choice. And a problem that I would like you to work on later this week, you're going to need to do something similar to this. So I'm going to ask them to enter a choice, and that's going to be a number. And then I'm going to have a loop that says while their choice is not equal to -1, do something. So let's just have a program that complements them in some way. I'll just say if their choice is, let's say, 5, I'll print out have a good day. Else if their choice is, doesn't really matter, let's say 9, I'll say print out you're looking great today. And then I'll have one more condition. I'll say else if their choice is 3, go ahead and print out ask again later. Right, and then at the end here, outside of all of these if blocks, I want to get a new choice. And it's going to look just like above. As a matter of fact, I'll just copy this directly here. All right, so let's take a look at what's going on here and then run the program. So with all Python programs, it's pretty reasonable to just read this in English and get an idea of what it's doing. So the first line here says assign to the variable choice what the user inputs when prompted by the phrase enter a choice, and we just have to convert that to an integer because I just want to use a number to make the program a little easier to deal with. So while the choice is not equal to -1, so as long as they haven't entered -1 for the choice, we go into this block here. And now we're inside the loop. So this stuff here is the code that belongs to the loop. It's indented one level, you'll notice. Right here, one indentation level. So inside the loop block, we've got if the choice is equal to 5, print out have a good day. Else if the choice is equal to 9, print out you're looking great today. Else if the choice is equal to 3, print out ask again later. And then at the end, after this if block gets executed, we ask for another choice. And so this will continue to run and continue to prompt them until such a time that they enter -1, when this condition up here will no longer be true, and so this loop will exit. So let's go ahead and run the program and take a look at how this looks in action. F5 to run it. All right, enter a choice. So I'll enter 5, have a good day, and it just says enter a choice again. I'll say 9, you're looking great today. 3, ask again later, and I can keep entering 3 for as long as I want because the loop is not going to exit until I enter -1. And you notice there's some options, like if I enter 2, that's just not going to do anything. It's going to ask me to enter a different choice. Okay, so I can keep going forever. But as soon as I enter -1 here, the program ends because I've met the condition up here and that's kind of called the Sentinel. That's where this name comes from. That's the thing patrolling the loop, okay? Great. And we'll come back to these in later videos and talk about them more. So, the other type of loop that I want to look at is called a counter-controlled loop. Now remember, both of these are basically equivalent, and you can write any loop with a counter or with a sentinel, but I think it's helpful to divide it up into these two categories. So a counter-controlled loop, generally you use this if you know ahead of time that you want to do something a specific number of times. You know the end condition in advance. In this case, we didn't really know when the user was going to want to stop entering numbers, okay? But now let's look at an example. Maybe I just want to print out the numbers 0 through 10 on the screen. Simple enough, right? So of course I could just say print 0, print 1, print 2, print 3, print 4, but that would take a while. And if I wanted to print 0 through 100, that would be a big pain, right? So let's look at how to do this with a loop instead. This is the power of a loop, that we don't have to specifically write each line like that. We can just tell the computer that we want to do this following command many times over and over again. So the keyword for this is for. So for, and the next component of this is a variable. So I'm going to call that I. It's customary to call it I, but this here is a variable. It can be just like any variable. You can call it anything you want. You can call it cheese or confetti or whatever, but usually we'll just call it I. And we say for I in range 0 to 11. And I'm going to say print I. Okay? And let's just take a look at how this works when I run it. I'll hit F5 to run. And we print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So, let's break this down. For I, so take this variable and give it every value in the range from 0 to 11. So this part's a little confusing. We always start counting at 0. Or we could change this, like if I said like 5 to 11, for instance, I'll get 5, 6, 7, 8, 9, 10. This first number is inclusive. So that's the first value that I gets. But you'll notice 11 is never printed to the screen. So this last number is exclusive. It's not included in this range. So that's why, even though I wanted originally the numbers 0 through 10 to be printed to the screen, I went with 11 as the last entry into the range function. Okay? And similarly, as I said before, in the naive approach to printing the numbers on the screen, like print 0, print 1, print 2, if I want it to, instead of printing 0 through 10, if I want it to print 0 through 100, that'd take me a long time. But with a loop, it's literally one change. So if I just type 0 up to 101, that means I want to execute this command 100 times now instead of just 10. All I did was change one place in my code, and now when I run it, I'll get the numbers 0 through 100 on the screen. Okay, and here. So this is fantastic and very, very powerful. Computers are good at doing tasks repetitively, very quickly, very, very quickly. So let's look at an example problem where a loop might be useful. And it's not really practical to think about doing such a problem by hand without the assistance of a computer or a loop. So hopefully you're familiar with the concept of a prime number. So a prime number is a number that is only divisible by itself and the number 1. So the first prime number is 2, the second prime number is 3, the third prime number is 5, and so on. So if I wanted to know what the 10,000th prime number is, how would I go about doing that? Well, let's take a look. I've got here a program that I've written part of already. This part up top, you don't have to worry about too much. It just defines a function that tells me whether or not a given number is prime or not. So the details of this aren't too important. Basically what it's doing is so this % sign here is called the mod operator. So it's checking whether or not the number input is divisible by any number other than itself. And if it is, it says false, otherwise it says true. So for instance, if I just print is prime 5, then this should say true, right? And if I said is prime 10, that should say false, because 10 is divisible by 5 and 10 is divisible by 2, right? So that can't be prime. If I said is prime 51, I think that's not prime, right? That's divisible by 17, I think. But if I said 33 or 31, that should be true, right? So it seems like it works. It just tells me true or false, is the given number prime? So this is a throwback to the value of procedural abstraction. I could give you this. You don't have to even care about how it works because it's pretty confusing to look at. All you need to know is that if you put a number in, it will report back to you, true or false, is that number prime? So let's go ahead and take advantage of this using a Sentinel controlled loop. So to make a variable, prime count. So remember the goal here, I'll put this in a comment, find the 10,000th prime number. Alright, so I'll make a variable called prime count, and I'll put that to 0. We haven't counted any primes yet at the start of the program. And I'll also make a variable for the current number, and I'll say that's 1. We're going to start counting at 1. 1 is not prime for technical reasons, but don't worry about that too much. 2 is the first prime number. So I'm going to say while the prime count is less than 10,000, and by the way, never put commas. This is a no-no. No commas in your numbers in programming languages, okay? So while prime count is less than 10,000, I want to get the next prime number, right? So I'll say I want to increase my current. I'm just going to count up current number equals current number plus 1. So we're just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to, along the way, check whether each number is prime. So if is prime, if the current number is prime, well, we just counted another prime, right? So prime count equals prime count plus 1. And I think that's it. Let's see. So when this loop is finished executing, we've counted 10,000 primes, right? And whatever the current number is the 10,000th prime. So let's go ahead and print it out. Print current number after the loop is finished executing. Alright, let's run it and see if it works. F5 to run. Alright, so my program has told me that the 10,000th prime number is 104,729. I have a website where that I found on Google that tells me the first 10,000 primes. Here's a list, and it says the 10,000th prime is 104,729, and that's exactly what we got, right? And if we scroll to the end of the list, we can see that here. So here's the 9,999th prime, and here's the 10,000th prime. Fantastic. So this is an example of how we could use a loop. And you'll have some other practice problems that are a little bit simpler than this, but hopefully this wasn't too hard to get your head around. And I think you'll have a lot of fun practicing with loops in the future.